Good morning. Today's topic is factors affecting acid strength. So, consider an acid HA. The extent of dissociation of an acid depends upon two factors. Okay, first one, strength of HA bond or strength of an acid. Okay, strength of an acid. And second one is polarity of HA bond. Polarity of HA bond. So, if an acid is acidic means, if it breaks, the HA acid breaks easily and form H plus ions, then we can say that the acid is strong or acidic strength increases. So, first point, strength of an acid. So, weaker the HA bond, what happens? More easily it gets dissociate and form H plus ions. So in that case we can say that the acid is strong or acidic strength increases. Okay. More easily it gets dissociated and form H plus ions. Means acidic strength increases or the acid is strong. Okay. This is the first case. Now, second case is polarity of HA bond. So, greater the polarity of HA bond means larger will be the electronegative difference between HA bond. Okay, that is there will be the difference between the electronegative difference between hydrogen and A atom. A is the electronegative atom, will be more easily the bond breaks and hence greater will be the acidic strength. Okay, greater the polarity. So, H is the hydrogen atom and A is an electronegative atom. So, greater the polarity of HA bond, greater will be the electronegative difference. Okay. Greater will be the electronegative difference of H and A. Okay, of H and A. So what happens? More easily bond breaks. Greater will be the acidic strength. Okay. Like this we can explain these two factors. Now let us take few examples, that is the elements present in the periodic table. We can easily explain down the group what happens and along the period what happens. We can explain that. Elements in the same group of periodic table. First example, elements in the same group of periodic table. What happens? So, we know bond strength, in this case bond strength dominates our polar nature. Okay, dominates our polarity. So, down the group, what happens? Down the group, we know size of the atom increases. Size of the atom increases. What happens to the bond strength? As the size increases, bond strength decreases. Bond strength decreases. So, HA bond easily breaks and form H plus ions. So, down the group, acidic strength also increases. This is the first case. Acidic strength increases. Few examples are group 17. Group 17. In the case of group 17, what happens? HF, then HCl, then HBr, HI. So down the group acidic strength increases. Okay. Next, group 16. Group 16 are H2O, H2S, H2O, H2S. Next, H2SC, H2Fe. These are the elements present in the periodic table down the group. Now, what happens in the case of period? Elements along the period. That is from left to right. From left to right. From left to right. Here we have to consider the polarity. Polarity decides the acidic strength. So we know from left to right electronegativity increases. From left to right electronegativity increases. Okay. As electronegativity increases, polarity of the bond increases and hence the acidic strength increases. Polarity increases. Polarity increases. Okay. Electronegativity increases. Greater will be the electronegative difference between these two atoms, hydrogen and A, H and A. So polarity increases and hence acidic strength increases. Example, CH4, ammonia, carbon, nitrogen, then H2O, oxygen, then HF. We know along the period what happens to the electronegativity? Electronegativity increases, so acidic strength increases. Acidic strength increases. Here down the group also acidic strength increases. Okay, these are the two cases. These are the two factors which affects the acidic strength.